S2 immediate annuities have the following characteristics. X pays 1 over m times per year for 10 years. Y pays P at the end of years 2, 4, 6, 8, 10. You are given S1, M, and S2. Present value of the two are equal. Calculate P. So first, let's recall what S1M is from lesson 66. We know that if there are M payments done per year, 1 over M each, which is the case over here, then S1M is the accumulated value at 1 year of all payments done in the first year. Now, there's nothing special about the first year. If we take starting time as 1 instead of 0, then S1M can also be viewed as the accumulated value at year 2 of all payments done in the second year. Similarly, it can be viewed as the accumulated value at year 3 of all payments done in the third year. So the point is that it's all payments done in 1 year. If you evaluate those at the end of that year, taking the beginning of that year as the starting point, then the accumulated value at the end is S1M. So therefore, annuity X is practically an annuity immediate where we have each payment as S1M, and it's an annual annuity immediate in that regards, because all the payments that occur during a year can be evaluated at the end of the year to be equal to S1M. So basically, it's a 10-year annuity immediate where each payment is S1M, and that's the usual annuity immediate that we are familiar with. And so the present value by equation 25.4 would be each payment, which is S1M in this case, times 1 minus 1 plus I to the negative 10 over I, where I is the annual effective interest rate. And we are given that S1M is 1.0331, so we substitute its value. And now Y was paying P every 2 years. And once again, we will need to convert Y into an equivalent annuity which pays every year instead of every 2 years, so that we can use the same interest rate I and equate it to this, and the I's will then cancel out. Now, let's first focus on S2. Let's focus on the first 2 years because it pays every 2 years. And once we understand what's happening in the first 2 years, we will know what's going on in the remaining years. And as mentioned in lesson 66, S2, which is given over here, S2, it's the accumulated value of an annuity immediate at time 2 if the annuity pays 1 at times 1 and 2 each. So if you have 1 at time 1, 1 at time 2, then the accumulated value at time 2 would be S2. Now, if instead of paying 1 at each of these 2 times, the annuity pays P over S2, then the accumulated value would be P over S2 times S2. Because we know that if instead of 1, the payment is X, then the accumulated value is just X times and the usual value where the payments are 1. So if the payments are P over S2, then the accumulated value at time 2 will be P over S2 times the accumulated value at time 2 of the annuity which pays 1 each, which is S2, and that comes out to be P. The S2s cancel out. Now, there's nothing special about years 1 and 2. We can use the same argument for each pair of years 3 and 4, 5 and 6, 7 and 8, and 9 and 10. So what we are seeing is that paying P at the end of 2 years is the same as paying P over S2 each year. Because if you pay P over S2 each year, we see that the accumulated value at the end of 2 years is P. So Y is equivalent to an annuity that pays P over S2 for each of years 1, 2, up to 10. And we can also add that it's equal to annuity immediate. So present value of annuity Y would be again by our basic present value equation for annuity immediate each payment, P over S2 times 1 minus 1 plus I to the negative 10 over I. And we are given that S2 is 2.075, so we substitute to get the present value of Y. Now we're given that present value of X equals present value of Y. Present value of X was this one, 1.0331 times all this, and equals present value of Y is P over 2.075 times all this. And so all the second factor cancels out, and you just have 1.0331 equals P over 2.075. From where if you multiply both sides by 2.075, we get P equals 2.14. That's choice E.